My name is David Lapen, and the title of this talk today is Environmental Change, Onehealth Observatory, ECO2, Ecosystem Services, and the Role of Hydrogeology. The authors Stephen Fry from Equanti, Donald Baird from Environment and Climate Change Canada, Nicholas Ogden from the Public Health Agency of Canada, myself, Agriculture and Agri-Food Canada, Osman Saidu, Engineering from University of Ottawa, and Hazen Russell from the GSC are authors on this talk about specifically this particular initiative, a Government of Canada initiative, the Environmental Change Onehealth Observatory, and the role of hydrogeology in it. It's important, and this is the core of the program, is understanding the impact and value of natural features in agro-ecosystems. Natural features in agro-ecosystems are clearly under stress in agricultural landscapes, and we're being lost at significant rates throughout Canada, either agricultural expansion, urbanization, etc. So what happens in the case that we lose so much natural area in these landscapes, and how does it affect the ecosystem services that they provide? The global aim of the ECO2 project, it's basically an interdisciplinary mission to characterize and ultimately value emerging, new, and existing benefits, ecosystem services, trade-offs, side effects of natural features in agricultural landscapes under changing climate and land use management practices. Some examples of natural features that we are evaluating are forest blocks, tree lines, fence rows, hedgerows, riparian areas, grasslands, natural wetlands, constructed wetlands. And we know that in many regions of Canada, agriculture is extensifying as a result of increasing crop heat units and land clearing that have a certain impact on the environment. So the project is very multifaceted, and we want to use as many layers, as many components, study points associated with comparing or evaluating natural features in these systems. And we're looking at greenhouse gas emissions, the aquatic ecology, terrestrial ecology, beneficial insects, biocontrol agents, vector-borne diseases, pathogens, flood, drought regulation. And we hope to kind of package these the study components up and put a value on them so that stakeholders, producers, and the environment writ large will have these will benefit from how these things impact broad targets in agricultural ecosystems. So this review underscores how groundwater is an important component regarding ecosystem services in the capacity that it supports provisions and regulates ecosystem services. And you can see in examples here of disease control for regulating floods, provisioning, of course, water, energy, genetic resources. And this is the core of the talk today, is to focus on groundwater, natural features, and ecosystem service. Firstly, land use conversions are important for projecting water quantity and quality changes in agro-ecosystems. And this example is from the South Nation River watershed in Eastern Ontario. When we want to understand the implication of say, natural feature losses, agricultural extensification, and urbanization, we need to project in a reliable way or as a way that has some fidelity spatially so that we can make more informed decisions about effects in the future. In this example, we evaluate both land use change and climate change concurrently to address things like, in this example, mineral P loading and hydrograph form for future scenarios. And you can see from the mineral P example that when we evaluate land use change and climate change together, it gives us a little different picture from evaluating future trends if we consider just climate change and land use change alone. So it's imperative to consider both climate and land use changes concurrently when evaluating whatever water quality or quantity target you're interested in. The project, and this is built from hydrogeosphere simulations in the South Nation watershed. It's showing recharge-discharge areas that, of course, have a certain temporal dynamic to them. But it's demonstrating, and we're finding that when modeled work is mapped like this, we can identify cold water species habitat and their links to glacial features such as eskers. And the cold water that is discharged into these systems will certainly benefit cold water species, and some that are considered species of concern or species at risk. So the approach here is to help target conservation efforts in these watersheds that are otherwise warm water systems. The effect of forest cover on total nitrogen and total phosphorus was examined in this watershed as well, and you can see the linear trends associated with phosphorus and nitrogen here, and that as forest cover fraction reduces, where we obviously expect that total phosphorus and nitrogen will increase, and that's at the expense of forests for conversion into agricultural or urban land uses. So it gives us some sense of the where we might want to, where we expect rather, some of these water quality targets to kind of exist under changing land uses and losses of natural areas in these agro landscapes. So focusing on some drought and flood regulation at watershed scales, a prairie example here, evaluating the importance of depression and wetland storage, the increased soil permeability associated with perennial grasslands, for example, and the surface roughness those grasslands might impose on the flood hydrograph. And we can see that certainly depression storage, increasing storage is important, increasing the infiltrability of the soil is important, and the surface roughness expressed here in crop is important for dampening the flood peaks. And so combined, we can see that through simulations that these expressions are associated with natural areas or minimally managed areas in these systems, and so it gives some support towards preserving them for, in this case, flood regulation. And many of us know that riparian zones also have a strong impact on floods. And in this case, we're evaluating the impact of riparian zones, healthy ones, on flood peaks. And just to give you some examples here from watershed regulations, you can see that by having a condition where you have a healthy riparian zone, flood peaks are dampened considerably versus situations where that healthy riparian zone is absent. Just to summarize quickly, some of the ecosystem services supported by hydrogeological modeling, and some of the generalized recommendations that this new project can make regarding hydrogeology and natural feature function in agroecosystems. Firstly, hydrogeology regulates and provisions ecosystem services strongly, and that hydrogeology is in itself regulated by these natural features. Ecosystem service regulating and provisioning is best evaluated via use of holistic integrated hydrological modeling tools, such as the hydrogeosphere model, and we can increase the fidelity of predictions into the future considerably using them. More specifically, riparian zones, perennial grasslands and wetlands help dampen flood peaks in watersheds, but they also increase biodiversity and sequester carbon, among other co-benefits. So we're trying to, again, within this talk here, kind of gauge the hydrogeological implication of these kinds of natural features, but there's a variety of other activities going on that are dealing with these other components, these other services, these other aspects, these co-benefits, so to speak. And again, we want to emphasize that future water quality and quantity projections must be evaluated using both climate change and land use change scenarios together. Using one or the other could give potentially, well, certainly different results, as we have seen regarding nutrient loading, as an example. And also, as we're learning more about this, glacial features like eskers that can support cold water intrusion into otherwise warm water systems is important for wildlife habitat, and potentially important for species at risk and species of concern, and the general ecological function of some of these surface water systems in otherwise warmer embedded in warmer water hydrological networks. And so much like source water protection for the case of drinking water, perhaps some of these glacial features should be protected for supporting the ecological function, the cold water function in these systems. So this is just a bit of a dim sum, a bit of a kind of an overview of the EcoTube project and its hydrogeological component. And with that, thank you very much.